Alright, I want to briefly go over scientific notation for you, and then I want to show you how to do proper arithmetic with scientific notation before we do the calculator work. So just as a reminder, scientific notation isn't something we use just to make huge numbers smaller or small numbers more manageable. The real purpose of scientific notation is to separate your significant digits and put them all together, take all the guesswork out of it, and then put your placeholding values on the other side. So with that in mind, if I give you a number like 18,500 and I want to put that in scientific notation, the first thing you always do is identify how many sig figs are in the number and what they are. So in this case, it's the 1, the 8, and the 5. The 2 zeros are just placeholders. So your decimal is going to go here. In proper scientific notation, it's always number, decimal, and then the rest of your sig figs, no matter how many there are. So to figure out how many placeholding tens we have, we're going to count over from where the imaginary decimal is. 1, 2, 3, 4 places. So that's going to be 1.85. And then here are those places, 10 to the 4. 4 steps. And we move to the left. And in this class, when we move the decimal to the left, we're getting bigger. So anytime you move left, you'll have a positive exponent. Logically, that makes sense. 18,500 is a big number. You should have a big exponent. Another example would be if we had something like 0.025. Again, identify the sig figs. It's the 2 and the 5 only. So we're going to move our decimal over 1, 2, needs to go right here. So my number is going to be 2.5 times 10, 1, 2, 3. And this time we move to the right, which means we're getting smaller, not negative, smaller, towards 0. And there's that number in scientific notation. One last example, if we had 0.00100, to put that in a scientific notation, I want to make you recognize that that's a sig fig, the 1, but also the last 2 zeros are significant. So they have to be in our number. We have to move the decimal over 1 place, 2 place, 3 places, and we will get 1, and then I'm going to put 0.00 because those 2 zeros are significant. Even though they won't change the math answer, we have to communicate their significance. Again, we move 3 places to the right, so that's -3. Now let's add with scientific notation. A lot of you probably think that you can just say 2.5 plus 4 here for these two numbers and get an answer, because they're lined up, you think, the way we have it written. It looks like the 2 is in the 1's place, and it looks like the 4 is in the 1's place, so you can just add them up. But that's not true. Remember, we have these placeholding values here. This 4 actually belongs to the 10's place, and this 2 actually belongs to the thousands place. So we can't just throw numbers together in scientific notation. What we really need to do is line these numbers up in their proper form. Like that. And once they're like that, we're doing first or second or even maybe in 3rd grade addition. It's pretty easy. Well, we don't want to have to do that. We're in high school. We want to be able to just look at the answer and make it a little shorter, especially if the exponents are 10 to the 12 or 10 to the -15. We don't want to be having to write them out and lining the decimals up. So what we have to do is that we have to make these exponents match. When the exponents match, all of your numbers will then be in the proper place value, like over here. As a rule of thumb, I like to take the bigger of the 2 exponents and make it equal the smaller one, because then I can avoid, for the most part, decimal numbers. So to do that, I'll need to take away 2 from the exponent of 3. To mimic that, I'm going to have to move my decimal over 2 places. So this top number becomes 250 times 10 now to the first. Take a moment and see what I did there. I wanted to lower this exponent to a 1, so I subtracted 2 from it. Because I subtracted 2, I had to go right. Remember, smaller means go right in this class. Now the other number is already 10 to the first, so I can just line it up like we're supposed to. 254. Now we can just add 254 times 10 to the first. Put it in proper scientific notation. 1, 2. That's going left. So we have to add to the exponent. And our final answer is 2.54 times 10 to the third. So that looks like it was probably a lot of steps. Again, with these small numbers, you're thinking, why is that even important? Because you could just write the numbers out like I did over here. But with huge numbers, these 3 or 4 steps I showed you would actually be faster. Let me just show you this real quick. If I had the same problem, 10 to the third, and then 4 times 10 to the first. What if I changed the 1 this time to a 3? So I would add 2, which means I would have to go 1, 2, and let's rewrite those numbers. Now it's 2.5 times 10 to the third, and 0.04 times 10 to the third. And you add those together. Just bring your exponents down like I did a while ago. 10 to the third. And then add your numbers together since they're lined up in the proper place values now. 2.54 times 10 to the third. Check it out. This time, we didn't have to fix the final answer to put it in scientific notation like we did here, because I turned the small exponent into a big one. Either way you want to do it, it's fine. It just depends on the way your brain thinks. So I'll let that be a personal decision. Alright, then multiplying and dividing have a different rule. And actually they're really kind of easier, I would guess. So 5 times 10 to the 8th, and I want to multiply that times 2.5 times 10 to the, 12. How about that? Now, we don't have to worry so much about place values lining up when we multiply and divide, so all we have to do is turn this problem into 2 halves. We're going to multiply the numbers together, the measurements. So 5 times 2.5 comes out to be 12.5. And then when you multiply and divide, you just add the exponents like you learned from math class. So 8 plus 12 is 20. And you've done the math. Way easier, way faster. Just make sure before you quit that you put the decimal in the proper place for scientific notation. I went left 1. Left is getting bigger, so add 1. Our final answer is 1.25 times 10 to the 21st. Division works pretty much the same. If we had 8 times 10 to the 8th, and I wanted to divide that by 4 times 10 to the 4th, do the same thing, just kind of divide the problem in half, do the numbers. 8 divided by 4 is 2. Now, in multiplication, we added the exponent. In division, you're going to subtract the exponent. So that's going to be 10 to the 8 minus 4. The final answer would be 2 times 10 to the 4th. Like I said, multiplication and division is a lot easier. Okay, final thing. In today's society, we don't have to do a lot of this by hand anymore because we have the calculators. Let me show you how to put these into the calculator. Let's take a real big problem. 1.18 times 10 to the 50. And let's add 2.5 times 10 to the 60. So that's going to be too big for us to do a lot with. But we can use the calculator. And the button that we need on the calculator is, depending on your brand of calculator, right above the number 7 on the keypad. Take a moment and find that real quick. The button that you want is called, or is labeled EE. And that's the 10 to whatever power button. I'm not sure exactly what the EE stands for, something with an exponent, I'm sure. But what you would do in the calculator is type in the top number 1.18 as is, and then you would hit that EE button. For some of you it's a second function. It just depends again on how your calculator is designed. But your screen should look like this. 1.18 E, and then you type in your exponent, which we said was 50. And that's what your calculator should look like. Then you hit the plus and do the same thing for the other number, 2.5, and there I go. Hit the EE button again, and then type in 60. So that's what your calculator, especially if you have a graphing calculator, should look like. And it will do all the math that we did earlier. What I want you to avoid is using the multiplication sign on your calculator and then 10 caret whatever, exponent 20, whatever. What this is going to do is give you the right number part of the time, and a good portion of the time you're going to be off by a power of 10 in your answer because you're doing this number here. You need to be in the habit of using the EE function on your calculator and not relying on the mathematical operators to make you feel good. So if you're not sure how to use this EE function, come and see me and we'll sit down and practice it together.